I'm a tutor in Uplatz. Today we are going to discuss about embedded hardware development skills. Embedded hardware development aims at build safe and cost-effective embedded systems that are easy to operate and ensure maximum performance with lowest power consumption. Simple and complex designs from concept to production. Build embedded systems for modern products, both consumer and industrial, telecom, consumer electronics, medicine, education, etc., to implement embedded hardware for these application areas. Steps in embedded hardware development include PCB design layout, FPGA design, hardware product design, prototyping, assembly, testing, validation, certification, preparing for manufacturing. PCB design and layout consists of the following steps: writing a technical specification, a schematic design, PCB layout, PCB fabrication and testing, mass production, and technical support. FPGA design consists of the following steps: architectural development, FPGA design, FPGA verification, the configuration of IP cores, CPLD design. Hardware product design: provide complete range of hardware product design by checking the feasibility of your product idea. After analyzing the product specification and all the input data, suggest several approaches to design and build device. During the development, product may undergo several iterations and reviews to achieve the desired result. Depending on the requirements, he is ready to provide a full range of hardware product design development. Prototyping and assembly: after the embedded board design and manufacturing, assemble PCBA to make prototypes to solder electronic components to a PCB. This is needed for testing and verification of the product. If any fault in the prototype, rework it. 2 or 3 iterations are usually enough to reveal most of the errors. Testing, validation, and certification: perform functional verification tests, product safety tests, and environmental tests on the prototype. After embedded hardware developer validates the prototype, it needs to be certified according to the required standards. To be certified, to ensure that the hardware is backed up by ecology compliance ROHS and some country-specific and device-specific certifications. Preparing for manufacturing: providing all necessary design documents needed to manufacture hardware, assembly drawing, gearbers, and other PCB production files, bill of materials, and our product structure, 3D models, and testing instructions. Embedded hardware development services include platform selection, prototype development, cost target, BOL, bill of material development, PCB design and circuit design, implementing and tests, ready to manufacture product development, experience with broad set of sensors, battery operations for targeted time development, meet power requirements. Responsibilities include design, develops, documents, tests, and debugs new and existing hardware components and systems, develops firmware in C and associated test code, create hardware specifications, design documentation, hardware-related detailed design documentation, bill of materials, and partless verification tests and reports, implementing analog and digital designs using schematic capture software tool or CAD, which include generating netless, partless, and printed circuit board layout, design layout, component placement and tracing routing, guide mechanical design for enclosures, work with testing agencies to ensure product compliance applicable standard, serves as technical experts on development projects, creates technical hardware specification based on conceptual design and business requirements, participates in code reviews, participates in design meetings and analyze user needs to determine technical requirements, consults with the end users to prototype, refine, test, and debug hardware and firmware to meeting needs. Skills required: experience using scope, logic analyzer, and standard lab tools, familiarity with compliance standards like MIL, SAE, FCC, EN, experience with embedded software development using C, experience with real-time operating systems for embedded systems, experience with debugging and testing all parts of analog and digital designs, experience with Python for software test development, experience implementing serial communication interfaces such as CAN, USB, I2C, SPA, RS-232, and RS-4. Way experience in analyzing unit failures and developing corrective actions, experience with managing products related vendor issues, experience with evaluating end of life and comp change notifications, sourcing alternate components, awareness of signal integrity and EMI, EMC issues. Lack of necessary flexibility for running applications or embedded systems. With the rising demand of connected devices, embedded systems need to work with heterogeneous devices and adapt to different networking architectures to cope with new functionalities and performances in the real-time environment. Due to this situation, increasing technology adoption and deployment of new applications, embedded system designers face several problems in terms of flexibility, which while developing embedded IoT systems such as problems in ensuring smooth integration of new services, difficulty in adapting to new environments, frequent changes in hardware and software facilities, issues in packaging and integration of small size chip with low weight and lesser power consumption, carrying out energy awareness operation, etc. The security crisis in embedded system design includes all the IoT hardware products need to perform securely in the real-time embedded environment. Since all the embedded components operate in a ID resource constrained and in physically insecure situations, engineers often face problems in ensuring the security of the embedded components. These systems have to be designed and implemented to be robust and reliable and have to be secure with cryptographic algorithms and security procedures. It involves different approaches to secure all the components of embedded systems from prototype to deployment. High power dissipation of embedded system design. Another increasingly aggravating limitation is power dissipation of microprocessor hardware design for getting the best performance of real-time applications and devices. The persistence challenge is how to deploy an embedded system with an increasing number of transistors and with an acceptable power consumption ratio. There are two causes of power dissipation in designing low power embedded system. First, because the power dissipation but transistor is increasing with the increase in gate density, and the power density of the system on chips is set to increase. Thus, the engineers must reduce overall embedded systems power consumption by using efficient system architecture design rather than relying on process technology alone. Second, the engineers focus on better performance with low power consumption by increasing the frequency of the system, which burns more power. Engineers need to pay more attention to design choices as well. Problem of testing and embedded system design. For ensuring a reliable product design, conducting in-depth testing, verification, and validation is another challenge. Embedded hardware testing. This is similar to all testing types where embedded developer use hardware-based test tools. This refers to embedded hardware tested for the system's performance, consistency, and validation as per the product requirement. Verification ensures whether the functional verification has been implemented correctly or not. Validation referring to ensure whether the product matches with the requirement and passes all the quality standards. Inadequate functional safety critical embedded systems. Functional safety is considered a part of the product's overall safety. Embedded systems are considered as generalized control systems which perform various control functions that require autonomy, reconciliation, safety, fault tolerance, and need to eliminate all the unacceptable risks to meet functional safety requirements. These considerations highly influence their use in applications where many functional loops are competing for the design of computational processes, due to which a number of timing and task scheduling problems arise. Increased cost and time to market. Apart from flexibility and security, embedded systems are tightly constrained by cost. In embedded hardware design, the need originates to derive better approaches from development to deployment cycle in order to handle the cost model or cost optimality with these electronic components and production quality. Hardware software code designers also need to solve the design time problem and bring embedded devices at the right time to the market. Changing phase of embedded development. A decade or two ago, the elements of embedded development included microcontrollers, assembly language, RC, OS, bare metal, or simple scheduler, user interface lights, which is text LCD, standalone devices, homegrown software code in ROM. changing phase of embedded development. Today, these took very different as reduced order costs now mean embedded systems typically have capabilities to equal to or greater than that of a high-end PC. From just a few years ago, multi-core microprocessor SoC, SOM with FPU, GPU, C, C++, Java, full operating system with file system, etc., touchscreen UI connected with other devices, Wi-Fi, Bluetooth, CAN bus, Modbus, IoT, cloud, etc. Third-party software like example Qt, regular software updates, features, and cyber security. The secret to success lays on the following points. How can Qt developer new to the embedded space succeed? Let me offer 4 pieces of advice gleaned from years in the field. Leverage existing software, don't reinvent the wheel. Do what you can to avoid making these common mistakes. Looking down hardware before any codes has been written, assuming UX design will be done once and never change, not doing formal UX design, developing on desktop and then porting to embedded, underestimating effort for testing, not enough communication between teams doing application OS hardware. Don't underestimate the effort necessary to set up your deployment tools and a stable OS with BSP. Always follow best practices, including use source code control, usually some form of Git plus web UI, continuous integration with automated builds, follow test-driven deployment or at least unit tests, measure test coverage, code reviews, the takeaways as the development of new technology accelerates, switching from desktop or mobile to Qt-powered embedded development offers great opportunity, but also many challenges. You can ease the transition by following some simple advice and closely adhering to the best practices. Hardware development engineer, the skill consists of hardware 9.8%, analog 6.5%, PCB 5.6%, prototype 5.3%, firmware 4.8%, and other skills 68%. Embedded hardware development skill matrix consists of high demand skills of 14, hardware, analog, PCB, prototype, firmware, circuit boards, RF, R2C, component selection, MATLAB, Ethernet, C++, circuit design, product development. Average demand skills are 15, UL, Serdes, DSP, CAD, design review, signal integrity, FPGA, test scripts, hardware, failure analysis, design verification, software development, 9 gigahertz. Low demand skills of 19, ASIC, internet test procedure, contrast, manufacturers, VHDL, BOM, DFM, USB, UART, LabVIEW, DF, MEA, PCA, IPCE, OEM, EST, DDR, DPS, IS4. Hardware is a high demand skill in hardware development, provide electrical engineering services during development and verification of weapon control hardware for Virginia class submarine program, provide hardware troubleshooting, debugging, support to software engineers during software development using logic analyzer and digital storage scope, implement IR contact enhancement algorithm in hardware to detect targets in ID camouflaged areas, develop qualification stress hardware, and oversee outsource reliability stressing required for new product introductions, integrate server hardware with customized applications for a diversity of consumer products configuration, develop strategy, create a flow and manage implementation of hardware quality and reliability, identify and interface with suppliers for qualification hardware and outsourced reliability stressing, develop electrical schematics, hardware designs, manufacturing process and test strategies, participate in hardware architectural design and provide feasibility study for best solution, perform initial validation and verification testing of new PCA hardware, develop avionics engineering practices, processes, procedures, and documents to comply with DO 254 design assurance guidance for airborne hardware certification. I had to manage all aspects of hardware development for various NASA life science project division experiments at Johnson Space Center, recommend hardware and mechanical design bug fixes to the design team, reducing implementation cost of $2 million annually. Work closely with the hardware core group and product development group in developing the next version of server switches, manage and define MP server hardware design specification, features, milestones, and overall product program schedule, develop and track hardware release schedules and milestones of set Judy's next generation device platform. Analog is another high-demand skill for embedded hardware development. Develop printed circuit boards for lab bench and test and production test of digital and analog integrated circuits. Assist in design development, testing, and manufacturing of analog and digital laser diode control electronics. Use of pulse analog circuit design for DTM speech filters. Develop embedded system boards, including analog IA interface, FPGA, ASICs, microprocessors, and memories, etc. Design, develop, test, and analyze high reliability analog and digital electronics for NASA research and development and space flight applications. Improve product capabilities, increase profit, and prevent a customer cost product failure by developing a new analog to digital interface. PCB design is another high-demand skill. Design several small PCB cards using mental graphics, schematic IT software, USB, TPS, motor drive card. Create and supports the release of Gerbers and BOMs to prototype and production of PCB board. Direct PCB layout to ensure signal integrity, EMI constraints, and design goals are met. Coordinator and took the design and test of all projects requiring a PCB design. Responsibilities include power systems, EMI, RFA system, cables, interconnects, high-speed PCB design. Increase productivity of PCB design department by 50% in peak business period. Complete designs of advanced PCB schematics and layout on aggressive schedules. Complete the board schematic and PCB layout for MTE text fixtures. Simulate PCB critical nets, timing, mental graphics, CAD tools. Experience with schematic entry and PCB layout verification using patch. Manage group of technicians, testers, and PCB designers. Design processor and memory PCB layouts using mental graphics. Design PCB test fixtures with SolidWorks. Use RF CAD tools, Agile and ADS extensively, and oversee PCB layout, employing best practices for layout. Design 10-layer 9U PCB back plans with VME bus specification. Design and layout PCB for USB 2 to dual squared circular daughter card for cart and trolley PCB above. Design and develop PCIe based PCB used for internet security with LSI security ICs. Gain extensive knowledge of multi-layer PCB level design manufacturing techniques. Complete design work including schematics, capture and PCB level using mental graphics, pads, design multi-layer circuit boards replacing schematics, capture and PCB layout tools. Prototyping is another high-demand skill for hardware development. Design several digital signal processing circuits for prototype software, including automatic gain, contrast control, and noise suppression. Design, test sonar, IR sensor, RF transceivers, and build a prototype robot for industrial application. Provide input to design, prototype, manufacture, and system testing to achieve working model. Direct design through layout phase, lab testing, and debugging of the prototype boards. Analyze issue on prototype, provided corrective action before product release. Evaluate design, prototype, document, and test PCs, sound cards, and modem cards. Firmware is a high-demand skill for embedded hardware development. Liaise with key clients, including clinicians, field clinicians, clinical engineers, firmware, and manufacturer teams. Work in the test department to evaluate the effectiveness of firmware and test scripts on the product drives. Develop a TMS 320C50 digital signal processing assembly firmware and VxWorks. Validate firmware for bill and coin acceptor. Validate fake bill and coin detection. 3. Design hardware firmware requirement specification using MKS doors for airborne motor and actuator controller firmware from system specifications using VHDL. Design AMD Mitsubishi 37700 based flash firmware, including boot application, power failure protection, redundancy check algorithm. Circuit boards is a high-demand skill for embedded hardware development. Increase profit margins by designing power supplies and circuit boards of cost-reduced laser sources. Design and develop printed circuit boards for company products, namely digital readouts. Design circuit boards for telephone switching equipment. Design of high-speed printed circuit boards, including schematic capture, component placement, constraint-driven routing. Design radiation hardened electronic circuits and printed circuit boards for satellite telemetry and command control applications. Perform electrical hardware design of circuit boards, peripheral devices, and wireless networking support circuitry. RF is a high-demand skill for embedded hardware development. Apply standard gate review, design process, control verification, testing of RF communication transceivers. Test and verify Products met RF and safety requirements, including UL, EMC, CE, Europe, and ELV. Work as RF development engineer who designed passive RF cards and modules that were used in cellular base stations. Work on RF board, power board system, and smart card encryption board. Assist RF specialists in the design of telecom laser diode mounts for RF research and development. Work on the some RF circuit with frequency synthesizers, modulation, and mixer design. I squared C is an idea and skill for embedded hardware engineer. Test I squared C devices on board and on system levels. Assign I squared C addresses and create memory map. Develop the I squared C communication interface in a computer controlled in field optical transceiver debug and reconfiguration. Develop software drivers to interface the SoC peripherals such as I squared C and UR. Design and develop I squared C controlled rapid IO thermal load card. Develop on a peak 32 creating device libraries to access sensors over an I2D C and SPI bus. Component selections and item skill perform complete design cycle, including schematics, capture component selection and board layout supervision, lead the component selection with respect to performance and lead time involved in technical design decision, component selection, cost analysis, and project scheduling, experience in vendor interaction from component selection to implementation of designs with microcontrollers, FPGAs, and NAND flash memory. MATLAB is an high-demand skill for embedded hardware development, performing dynamic system simulation and modeling with MATLAB and free-space skill analysis. MATLAB skill card products use MATLAB for data power, use MATLAB as a tool of choice, perform extensive verification simulation on successfully completed design, which compared favorably to a theoretical model in MATLAB, correlate results against an Agilent spectrum analyzer and also MATLAB simulations. Ethernet is an high demand for embedded hardware development. Track down a software error in the Ethernet interface configuration by analyzing the interaction between the MAC and PHY components. Maintain the Ethernet network in the above mentioned lab. Experience with software development and from the embedded system using multiple IO cards, including USB and Ethernet. Develop FPGA board with DDR3 interface, PCIe, PCIe switches, USB 2.0, 3.0, Ethernet, HDMI, and SD interface. Perform high-speed logic design of PRNG, Ethernet, OC48, OC192, and serialize and deserialize into FPGAs. Incorporate a 10 bar 100 host Ethernet management interface, PCMCIA interface, management instruction interface, and finance management interfaces. C++ is an high-demand skill for embedded hardware development. Develop code and tools in C++ for memory controller, backup, and characterization for memory subsystem. Develop, modify C, SPA, PP, C750 base, BIOS, and driver code. Create libraries in C++ and C# to allow SDEs to write software for the field devices. Implement C++ modules for different data manipulation, filtering, and conditioning. Perform hardware firmware testing with Visual C++ code developer. Work on C++ implementation of Intel embedded graphic behavioral specification. Circuit design is an high-demand skill for embedded hardware engineers. Circuit design textures instruments, digital light processor, DLP, video card for high definition DLP TV. Use space for circuit design simulation and hyperlinux to verify signal levels and other parameters. Compete circuit designs on mobile laptop platforms using Cadence, OrCAD, and Allegro design tools. Work on flyback power measurements and circuit design for MTE designers on PoE boards. Perform circuit design and board layout for Striker EMS power load system using OrCAD Cadence tools for all the above mentioned multi-layer ASPs. Order and research all electronic components used for preliminary circuit designs. Product development is a high-demand skill for embedded hardware engineer. Interview and mentor 2 interns and 1 IR engineer in research and development of consumer product development. Work to support aggressive project schedules in a fast-paced dynamic product development environment. Participate in design reviews with new product development activities in PD. Perform FMEA and DOE for product development. Involved in all phases of product development, including pre- and post-release activities. Analyze technical problems related to product development, processes and services, and implement solutions. UL is an average demand for embedded hardware development. Conduct tests at product level as per UL, EMC, and CE requirements. Coordinate UL certification and solve radiated emission problems. Add power sharing and protection circuitry and perform production validation to confirm design and when UL approval, perform complex testing of the designs to verify adherence to applicable standards from SAE, UL, FCC, etc. Printed circuit design for switching power supplies that qualify for UL, CSA, VDE, safety, agency approval requirements, manage entire organization regulatory compliance with CE, UL, FCC, ingress protection. Service is an average demand scale for embedded hardware engineer. Here is how service is used in hardware development engineer job. Develop the XIO FPGA, which bridges between XGMII and 3.1 to 5 GPPS Serdes Average IO plus. This is an average demand for embedded hardware engineer. Design the code reader using the high-speed IC and TMS DSP. Study on automatic recognition and features extraction for vehicle targets and algorithms implemented based on the DSP. Adopt digital signal processing chips used for telecommunications into companies' products and help software engineers optimize system performance, achieve low rate protection contract with using redesign personal identification design with DSP, design DSP based electronic code to decode 12 bits position feedback for XY linear motor moving on a two-dimensional grid array. Design net audio which streams audio via 10 bar 100 base T network or Wi-Fi network based on TI's DSP TMS 320C54. CAD is an average demand for embedded hardware development. Learn CAD tools for schematic capture and printed circuit board layout. Create library part shape requests to the CAD library and support manufacturing with procedural documentation and CAD drawings. Deliver FinFET aging model simulation research to design and CAD groups for reliability enhancement. Prepare customer site engineering reports, which included detailed specification, instruction, test procedure, and CAD drawing. Design and modify engineering schematics for electrical transmission and distribution system. Use CAD computer-aided design software. Design reviews average demand scale for embedded hardware development. Perform schematics captures, symbol creation, product selection, comparability verification, and design reviews for the circuit being developed. Participate in design reviews from conceptual to physical design. Develop W-line switch router module for Samsung YS7200 series. Create system requirements and specifications. Conduct design reviews and customer specifications, and develop test plans and procedures. Lead internal prototype development using multiple outside vendors and in-house resources for executive marketing, design reviews and approvals. Attend internal and supplier design reviews to answer questions related to prediction calculation, reliability testing methods and procedures. Attend specification and design reviews to answer questions related to environmental qualification test methods, test requirements and schedules. Signal integrity is another average demand scale for embedded hardware development. Coordinate with signal integrity experts to investigate and implement cost-effective probing technology for eliminating crosstalk on wire one type probe cards. Perform system and board level signal integrity and parametric tests using lab devices. Perform signal integrity simulation using ICX tool, and perform board level testing of differential and critical signals to correlate simulation data. Validate timing and signal integrity, adjust termination and document all high-speed critical signals. Perform signal integrity experiments using oscilloscope, logic analysis, and spectrum analysis to uncover complex issues with ASIC packet. Utilize routing, constraint, termination techniques, and simulation software to preserve signal integrity on high-speed transmission lines and reduce emissions. FPGA is an average demand for embedded hardware development. FPGA stands for programmable gate array. In general terms, an FPGA is a hardware circuit that a user can program to carry out one or more logical operations. They are programmable silicon chips surrounded by input output blocks that come together through programmable interconnected resources to become a digital circuit or system. It is compatible with both simple and complex functions that together act as a comprehensive multi-core processor. FPGAs are used in a wide spectrum of area, from equipment for imaging and video circuit to circuitry for auto, computer, aerospace, military application, and electronics for specialized processing. Here is how FPGA is used for hardware development engineering job. Design more than a dozen FPGAs ranging from several thousands to 50K plus gates. research and scale BCHIP and for NVD, resulting in accurate FPGA utilization estimates, review the FPGA functionality and code for a design, review, test FPGA control and status, modify and update FPGA test GUI, check FPGA's reference clock, PLL, VCXO, full range, and the phase margin gain to stability with Venable. Develop Xilinx Spartan 3 FPGA in VHDL for receiver card in Acron Digital Radio. Develop code to implement CAN IP into Altera Cyclone 4 FPGA on control board. Design include Altera Apex 20K PLD FPGA and VSA DS1 interface. Work with Altera FAE on FPGA implementation, board design review. Work on vision systems and implementations on Xilinx FPGA. Set up test environment in various labs and program FPGAs. Experience simulating board level and FPGA designs using model sim or including test bin development. Experience with embedded logic analysis as well as desktop logic analysis and scope to debug high-speed FPGA and board level problems. Experience with Xilinx ISC 10.1 tool for VHDL code maintenance and programming FPGA devices using high impact 10.1 software. Design, test, and document high-speed optical transceiver evaluation boards incorporating Altera CPLDs, FPGAs, and EEPROMs. Use Xilinx Alliance for place and route and timing verification of Xilinx Vertex E FPGAs. Work with Altera and Xilinx FPGAs, Altera NIAS 2 embedded processor, and Xilinx Zinc SoC. Test scripts is an average demand for embedded hardware development engineer. Test scripts validate the quality of software or app being tested, and effective test scripts has all the steps to be taken to use a software program as well as the ending the result of each step. Here is how test scripts is used in hardware development engineering jobs. Develop and determine modification for automated test script. Debug modified test scripts to fully automate EDVT testing. Develop manual and automated test scripts libraries. Write test scripts for testing military aircraft weapons delivery systems using proprietary scripting language. Support testing and development department with new test scripts to shorten testing time. Execute detailed test scripts including unit tests, user scenarios, new features, integration, regression, and stress testing. Hardware is an average demand for embedded hardware development engineer. Define, document all aspects of security hardware architecture and microarchitecture specification and the internal hardware functions of discussions and interfaces. Control hardware producers, variable signal frequency, duty cycle amplifiers who are a wide range of frequencies. Support customers and resolve hardware sustaining issues and work on cost reduction efforts. Design ultra low cost controller in condensed time frame, 3 months from spec to completed hardware. Team leader responsible for hardware design, hardware and software integration and implementation of new device into MPU system. Develop and maintain verification tests for MPA and return hardware components. Failure analysis is an average demand for embedded hardware development engineer. Failure analysis is a step-by-step process of determining the reason for a particular machine or equipment failure by way of checking, identification, and examination. It means conducting a test within the system and perform a maintenance check that leads you to a conclusion. A failure analysis takes place to prevent further damages. Here is how failure analysis is used in hardware development engineering jobs. Conduct theoretical, experimental, predictive failure analysis. Perform board bring-up, validation testing, and failure analysis at the factory overseas. Assist with manufacturing, purchasing with part issues, failure analysis, cost reduction, second sourcing effort, and elimination of non-value-added activities. Perform failure analysis on electrical failures and provided solutions to correct problems and increase reliability. Support current production design, including quality improvement, cost reduction, and component obsolescence and failure analysis. Perform engineering failure analysis on field return products and present findings to customer and account teams. Design verification is another average demands for embedded hardware engineer. Design verification can be defined as the examination and evaluation that leads to confirmation that the objectives have been met and specific requirements of a particular design have been fulfilled. It is a process through which you can test your design outputs to see if they match your design input. Here is how design verification is used in hardware development engineer's job. Utilize Altium to perform necessary design work, including design creation, design analysis, and design verification. Serve as hardware engineer, providing design verification for new controller designs according to the specification, and controller pilot engineer, conduct requirements captures and peer review, and develop technical documentation, design verification, and test specification, collaborate with cross-functional teams to participate in mechanical design and implementation, assist in software debugging and design verification testing, perform circuit analysis and best characterization of components for design verification testing and isolating any failure, perform design verification test for enclosure management, submodule, including FPGA functional and timing verification to ensure high quality and functionality. Software development is an average demand for embedded hardware development engineer. Software development cycle is the mechanism by which the programmers create computer programs. The software development life cycle is the framework for developing applications that follow technological needs and consumer requirements. It consists of many stages. The SDLC establishes an international standard that software developers can use to enhance and create their programs. It provides a well-defined framework for software developers to pursue in the production, maintenance, design, a premium quality software. The aim of the software development process is to create high quality software on time and within budget. Here is how software development is used in hardware development engineering job. Create the Red development board for Windows C based software development using Intel's X scale processor, monitor health and status of assigned networks and associated devices through specialized and commercial software solutions. Conceive and direct the test platform software development activity, define the system and manage the entire and work with the programmer for the software development of the entire system, support development, software development, hardware configuration, system software testing, and process and product audit. Provide system integration and software development for a remotely controlled cooling system used to clad the inside of steam generated tubes. Linux is an average demand for embedded hardware development. Linux is a Unix-like operating system, just like Windows, Mac, OS, and iOS. Linux is an operating system used by millions across the globe. Android itself is powered by the Linux operating system. Linux manages all the hardware resources that are associated with your computer. The software is famous because of the protection it grants from viruses, malware, and crashes. The Linux operating system is entirely free and is an open source, meaning it can be altered by those who are equipped with the knowledge of the code. Here is how Linux is used in hardware development engineering jobs. Experience with Linux scripting in developing small tools for automation, perform Linux system testing and verification of cellular Bluetooth, Wi-Fi connectivity, design and build specialized Linux kernels for a variety of hardware configurations, including PowerPC and Intel chips. Install, configure, and test a number of Linux distributions for development server, code, and I2S driver and Linux ISR to manage voice buffering between a network processor and a slick. Work on C scripts for the data acquisition system to collect data and store the acquired data on a Linux server. GIGAS is an average domain for embedded hardware engineer. Here is how GIGAS is used in hardware development engineering job. Design serial trace pod circuit for high speed up to 12 gigahertz trace collection. ASIC is a low demand skill for embedded hardware development engineer. Design verification and test development boards for ASIC design. Peer review, power quality measurement, hardware in description language on $1 million ASIC program. Coordinate the design development, characterization, and reliability qualification of Oracle's industry's leading ASIC semiconductor packaging. Participate in E100 early architectural system definition, partitioning, and ASIC chip selection. Participate in building the company FPGA ASIC development methodology and definition of verification strategy and environment. Co-develop architecture and verification of ASIC development, coordinating with ASIC development team. Internet is a low demand skill for embedded hardware development engineer. Internet is a worldwide virtual networking medium that connects computers all across the world. Net is a short for the internet. It has millions of smaller networks that carry a huge array of information. Here is how internet is used in hardware development engineering job. Develop a core multimedia access with GPS tracker and internet browser. Test procedure is a low demand skill for embedded hardware development engineer. Test procedure is identified as a tool for conducting an experiment to analyze and observe the specification of a process or application. Here is how test procedures is used in our development engineer job. Create detailed test procedures, drawing documentation, and follow change control process. Develop qualification test procedures and conduct qualification testing, and also conducted testing and integration testing for functionality and limits. Support development of factory diagnostic software, document the test environment, and deliver a detailed factory test procedure. Create test procedure and coordinate the test activity for manufacturing group and diagnostic developers to ensure complete test coverage of server product. Implement the test procedure that verify hardware and system module without in-depth documentation that was adopted by product and the process documentation required for hardware testing, including generation and updating of functional test procedures and test diagnostics. Contract manufacturers is a low demand skill for embedded hardware development engineer. Work with contract manufacturers and suppliers throughout Asia on tooling, molding, and assembly process. Manage internal and external layout resources and contract manufacturers on scheduled and cost. VHL is a low demand skill for embedded hardware development engineer. Here is how VHL is used in hardware development engineer's job. Design new VHL blocks, including interface between NIAS processor and MONC data transfer system. Design programmable logic devices in VHDL and use quadus timing analysis for timing analysis. Work on multinational projects as leading team member, developing image processing and inter-processor communication VHDL models. Well-led design changes when encoding, decoding actual image files through VHDL simulation. Design digital D1 television color for generating VHDL. Synthesize VHDL code using Assembler, Leonardo specs and synthesis software. Bill of material is a low demand skill for embedded hardware development engineer. BOM stands for bill of materials in design drafting. This list outlines the raw materials, instructions, and components required to manufacture or construct a product or service. Areas of BOM is used in hardware development engineering jobs. Qualify and approve components on BOM, including conversions to ROHS. Enter and manage BOM in database for sign calls. Develop manufacturing documentation in BOM. Generate BOM file and some electronic investigation with partially Altium's X-Space simulation in some circuit. Create all related engineering information for new products such as drawings, BOMs, and 3D models. Create and maintain bill of materials for product acquisition, requisition packages. DFM is a low demand skill for embedded hardware development engineer. Design for manufacturability or DFM is an engineering methodology used to create a product that is easy to both manufacture and use. When taking DFM into consideration, engineers look into relevant processes, information about the product, and ways to make future upgrades easy for designers, engineers, and other experts who use DFM. Their main goal is to create a product that is easy to produce at a reasonable price. This can be done with carefully aligned steps and compromise through the design process to create a product design that maximizes usability and minimizes cost. Here is how DFM is used in hardware development engineer jobs. Learn critical lessons and design techniques for EST and EMI mitigation, as well as DFM. Create and maintain component specification content that meet PCBA, DFM, and DFT requirements. Job responsibility: schematic entry, layout edit, DFM and DFT. Monitor manufacturing, build yield, address design and DFM issues. Work with manufacturing to incorporate changes in new designs that improve design for manufacturability, DFM. USB is a low demand skill for embedded hardware development engineer. Develop internally shielded USB cable to achieve savings of $1 per box on multiple products. Develop and execute test plans in USB protocol, functional compatibility testing and reliability. Develop, debug, and release USB distribution of network for environmental calibration platform. Test USB functionality and compatibility. Debug systems in the lab, such as finding Y and OHCI USB devices file and replugged into another port in WinC to 5.0. Redesign existing product to convert communications from RS-232 to USB. UART is a low demand skill for for embedded hardware development engineer. A UART is also known as Universal Asynchronous Transmitter Receiver is a computer hardware device for asynchronous sequential communication where the data format and transmission speed are configurable. Transmission of data between two UARTs required only to create and implement algorithms which are instructions that enable the hardware to operate. Here is how UART is used in hardware development engineering jobs. Design include TTL serial interface UART with GSM radio module using standard AT command. Add UART VFM to verification environment. Manage the testing programs for the total codes of DDR2, UART, PCIe, and Flash. Automate testing of I2S, UART, SDIO, and VCM interface. Reduce test time by 80%. Add UART interface on M4V ODU digital board for antenna control, including adding UART chip and FPGA VSC modification used in multiple cockpit display projects, button switch and encoder board, and security design with UART interface for data output. WC low demand skill for embedded hardware development engineer. Develop a LabVIEW application to automate the data acquisition of the qualification performance data. Develop a LabVIEW application to remotely control the sleep tooling with a TCP/IP link. Design, implement, test, and document hot air solder reflow system using a LabVIEW implemented in PID controller. Manage the development of a LabVIEW driver for the multi-axis motion controller. Define feature requirement for LabVIEW code developed in collaboration with outside vendors. Complete test of LabVIEW applications. DFMEA is a low demand skill for embedded hardware development. DFMEA stands for Design, Failure, Mode, and Effect Analysis. It is an analysis tool that pertains to the systematic group of activities that evaluates and determines the potential risk, failure points, and effects of different actions. Here is how DFMEA is used in hardware development engineering jobs. Develop BOM, DVP, and R packaging area, and DFMEA for new product design. Perform DFMEA analysis together with cross-functional team on the projects. Direct DFMEA, PFMEA, and DFM activities during electronic component development. Identify DFMEA for controller and peripheral subcircuits and drafted up plans to reduce RPN per ports. Develop the DFMEA for RF external and internal antenna variants. Design a 2 amps sourcing on-off driver and to write the supporting design documentation. DFMEA, WCA, SA, and SCDR. PCA is a low demand skill for embedded hardware development engineer. Design and build a PCA-based board which was responsible for the safety, interlocks, and controlling key subsystems of the XT250. Design a power PC control board with SDRAM and flash, providing a PCI and local bus, compact PCI T1 even, and design conversion in a compressed time frame with no software impact. Result in company's first data acquisition board based on PCI. Lead successful architectural design of highly integrated SS7 PCI Express board. Apply for 2 US patents on the CPU thermal solution and the extensible PCI bus or ribbon cable solution. IP is a low demand skill for embedded hardware development engineer. Test board in temperature chamber with smart bits 6000B and external IP test set. Work on verification of embedded CB, RAM, IP module using system log assertions and Gustav Sim environment. Receive Vice President level award recognition for efforts developing the IP gateway product. Configure servers with IP addresses, install router and switch iOS, and install and test software. Initiate and lead IP development program. Identify IP white spaces. Program each unit with IP security and administration info. C is a low demand skill for hardware development engineer. Redesign operator controls for ultrasonic welding equipment to be CE safety compliant for factory workers. Design program embedded Windows CE devices. Support EMC testing and resolve problems for successful CE certification. Organize complex testing and certification activities to electronic subordinates to international specification. CE, EMR, CTIC, FCC. OEM is a low demand skill for embedded hardware development engineer. Work with and lead technical discussion with OEM to solve reliability and design issues critical to the project's success. Review and evaluate multiple external OEM scanner suppliers on image quality and teach a site-wide scanning fundamental courses, co-develop with two different scanner vendors a similar carriage designed to better understand their ability as OEM vendors, lead technical communications with OEM vendor, and collaborate to solve design issues. EST is a low demand skill for a embedded hardware development engineer. Work directly with customers on boards, system failures, which resulted in designing EST protection on Ethernet boards. Suggest several EST safe engineering tools for future use. Pass EST testing at RET-LIF laboratories. Manage EMC and EST issues and complaints. Design boards for functional correctness, excellent signal integrity, low cost manufacturing, FCC, CE, EMI compatibility, and EST tolerance. DDR is a low-demand skill for embedded hardware development engineer. Design solution included use of DDR IOs attaching 512 MB interface with a say 7226 address running 125 MHz DDR 2.5G. Links supports four priorities per destination. Design consists of PowerPC microprocessor, PCM bus interface, GPT Ethernet interface, DDR, flash memory, and Xilinx FPGA. Board include 805P North Bridge, 6300 ESP South Bridge, and 2 MB DDR SDRAM. Design a 500 MHz LVDS DDR data channel between a Vertex 5 and a Spartan 6 FPGAs using VHDL. GPS is a low demand scale for embedded hardware development engineer. GPS stands for Global Positioning System. It is a navigation system comprising of satellites that helps in determining the location, velocity, and surface time data for different modes of travel like air, sea, and land. Here is how GPS is used in hardware development engineer jobs. Develop GPS code with microelectronica in language C. Conduct extensive testing and sustainment of the GPS receiver and BIU system, CSU, DSU, T1. Develop FPGA per Rockwell Collins technical consistent process for safety critical commercial GPS learning application. Design system timing card for CDMA 2000 base station system, which synchronize local clock to GPS satellite clock and provide timing information. Design and implement communication interface with GPS receiver to retrieve its subframe data and time mark pulse TMP. Continue the process of reduction to familiarize myself with various aspects of GPS alpha implementation in a JTIS IDS environment. ISO is a no demand skill for hardware development engineer. Maintain all validation equipment calibration for ISO certification requirements. Possess extensive knowledge of ISO procedures and documentation in the following: CDSU, ATMI, GPSR, and VSM products. Automate interfaces for connecting Altium schematic PCB designs with companies AS400, ISO 9000 compliant system. Thank you.